Hi there, Mr. Sutton here, bringing you the Algebra 2, either the 4-5 Part 3 homework if you're doing the CP non-honors, or the 5-4 Part 2 homework if you're doing the honors version of this. And then the non-honors, we're doing 1 through 3. Honors has problem 4 as well. So this topic is going to be solving polynomials by using the rational roots theorem. To find the solutions of this equation, we're first going to check to see if we can do this by regular factoring means. So there's no common factors we can take out of this. If you're trying to do this by grouping, because there's 4 terms, you'll find that if you take out an x squared and have x minus 10 and take out a 1 and 19x plus 30, none of that is going to work out. So we're going to go to the rational roots theorem and generate our possible rational roots list. So this will be positive, negative factors of 30 divided by factors of 1. So factors of 30, we've got 1 times 30, so we've got a 1, 2 times 15, so 2, 3 and 10, so 3, and then 5 and 6, and then we said we had 10, 15, and 30. And we're dividing all of these by 1, so we don't really have to write the fraction there. All right, so these are all the things we're going to plug in now using Desmos to see which of these gives us a 0 when we plug it into the original equation. So here I am on the Desmos scientific calculator. I'm going to create a function. I'll call it f of x to represent my polynomial here. So x cubed minus 10x squared plus 19x plus 30. And then I'll make a new entry, and I'll just start plugging in these PRR numbers into this function until I get 0. So let me start with the 1s here. So we got f of 1, which gives us 40. That's no good. F of negative 1 gives us 0, so that's nice to get a 0 so early in the process. So I'll just write here calc f of negative 1 is 0, just to let people know what I'm doing. So I'm going to use synthetic division now with negative 1 as my k value to break this down a little bit further. So let me write my coefficients of my polynomial. We have a 1 for the x cubed, and then negative 10, 19, and 30. And then negative 1, again, that is our k value that we're plugging in. So let me draw my line here and bring down my first coefficient of 1. Negative 1 times 1 is negative 1, plus negative 10 is negative 11, times negative 1 is 11. And then we've got 19 and 11 gives us 30. Negative 1 times that is negative 30. And then that adds up to 0, which is good because it should, right? Because if you get a 0 this way, you should get a 0 with the remainder as well. So I can factor this into x minus negative 1, or x plus 1. And then this quotient here, this 1 stands for 1x to the second. We're one exponent lower than the x cubed here. So 1x squared. This is minus 11x. And then plus 30. And it looks like I could probably factor this a little bit more, so let me bring down my x plus 1, and then I'm looking for numbers that multiply to 30 and add up to negative 11. So 1 and 30 doesn't work, 2 and 15 is no good, we've got 3 and 10, still no good, 5 and 6 works if they're both negative, so x minus 5 and x minus 6, and now that I have this fully factored, I can just go through and get the zeros. So we have x equals negative 1 for that first parentheses, and we already found it up here anyway. And then we have 5, because 5 minus 5 is 0, and then 6 for this last one. Next up, we're trying to find solutions of this equation. So let me first check to see if I can do this any other way other than rational roots theorem. It looks like we can't take out any common factors. This 3 is messing us up to try to take out a 2. And if I try to use grouping, I've got an x squared coming out of this to give me 2x minus 3. Over here, I mean, whatever I take out, I'm not going to get 2x minus 3. So I can abandon grouping and go straight to rational roots then. So let me get my possible rational roots list. We're going to have factors of negative 24, just factors of 24, divided by factors of 2. So factors of 24, and these first several are going to be just divided by 1, the factor of 2, 1. So we're just going to write the number in the numerator here. So 24, I can get that by multiplying 1 times 24, and then 2 is another factor. 3 times 8, 4, and 4 times 6 gives us that pair. And then we had 3 times 8, 2 times 12, and then 1 times the original number, 24. Now I can also do all of these numbers divided by the other factor of 2, which is 2. So we've got 1 over 2. 2 over 2 is just 1, so I don't need that. 3 over 2 is unique. 4 over 2 is just going to be 2, so I don't really need that. And I think I said 2 over 2 is 2, it's 1. Anyway, moving on, all these even numbers we've already seen before. You're just dividing by 2 and getting another one of these numbers. So the only unique factors over 2 are 1/2 and 3/2. Let's go and start plugging some of this in to get a 0. So let's go to Desmos for that. So I'm going to create a function, f of x, to represent my 2x cubed polynomial here. So we've got 2x cubed minus 3x squared minus 50x minus 24. And I'll start plugging things into that by doing f notation down here. So we'll start with the 1s. We have f of 1 is negative 75. f of negative 1 is 21. Let's do the 2's now. So positive 2 gives us negative 120. Negative 2 is 48. Let's move on to the 3's. 3 gives us negative 147, and negative 3, 45. So far, these aren't even close. Let's try the 4's. 4 gives us negative 144. Negative 4, there we go. That gives us 0. So we've got f of negative 4 is 0, so let's plug in negative 4 with synthetic division. My coefficients up here, I've got a 2 for the 2x cubed, and now negative 3, negative 50, and a negative 24. And again, we're plugging in negative 4 for my k value. So here's my division line. I bring down that first coefficient of 2. Negative 4 times 2 is negative 8, plus negative 3 is negative 11, times negative 4 is 44, plus negative 50 is negative 6, times negative 4 is 24, plus negative 24 gives us the 0 that we were hoping for. All right, so we've got x minus negative 4, or x plus 4 if you like, and then my quotient is going to be 2x to the second power because we started with third power, so 2x squared minus 11x minus 6, all of that equaling 0. At this point, now that I've got it down to a quadratic, I can either try to factor it a little bit more, or I can use quadratic formula, lots of options. Let me at least check to see if I can factor this. If I do, I'm going to use the AC method. So 2 times negative 6 would give me an AC value of negative 12. And I'm hoping there's two numbers that multiply to negative 12 and add up to negative 11. 1 and negative 12 does the job. So we can definitely factor this. So I'm going to rewrite all of this with only one change. I'm going to split this negative 11x up into a plus 1x minus 12x. Right there. Even put it in red for you. So now we've got the x plus 4 that we initially had there. And I'm going to take an x out of these first two terms, leaving me with a 2x and a plus 1. For the next two terms, I think I can take out a negative 6 from those, and that leaves me with a 2x and a plus 1 there as well. So I've got the x plus 4, I've got this 2x plus 1 that I can yank out of everything, and then I have this x minus 6 that's left over. Now that it's fully factored, I can go through and just get the zeros out of this. So if x plus 4 equals 0, then x equals negative 4, which we actually already found earlier on. For 2x plus 1 equals 0, I can subtract 1 and divide by 2 to get negative 1/2. And 6 minus 6 zeroes out that last factor. So those are my three answers for this one. For this polynomial, we're trying to zero out the function. So just as we always do, we're going to see if we can do this by factoring, which you'll discover you can't. There's no common factors to take out, and you can't even really try grouping on this one. So let's move on to rational roots theorem and see if that gets something going. So let me do my PRR list, possible rational roots. We've got plus or minus factors of 48, the constant, divided by factors of, well, we just have a lead coefficient of 1. Factors of 48, we've got 1, 2, 3 goes into 48, 4 goes into 48, 5 doesn't, but 6 does. 6 times 8, and then we had 4 times 12, 3 times 16, 2 times 24, and 1 times the original, 48. And these are all just factors of 48 divided by 1, so we don't need to do anything else here. So let's go ahead now and start plugging these into the function, which I'm going to do on Desmos, until I get a result of 0. So here on Desmos, let me set up my function f of x equals x cubed minus 28x minus 48. And let me do f of 1 to start the bidding here. That comes out to negative 75. I'm trying to get 0, so let me plug in negative 1. That gives me negative 21, and I'm just going through this list in order from left to right. Next up, let's try the 2's. 2 gives me negative 96. Negative 2 gives me 0. Excellent. So negative 2 is one of my roots. I'm not guaranteed that there's any other rational roots, so let me just use synthetic division on this to get things down to a quadratic. So using synthetic division, I do have to be a little bit careful here. We have a lead coefficient of 1, and then we have a missing x squared term. So we actually need a placeholder 0 for that. Then negative 28 and negative 48. And then negative 2 is our k value in our little box here. So here's my synthetic division line. Let's bring down that first coefficient of 1. Negative 2 times 1 is negative 2. 0 plus that is still negative 2. Negative 2 times negative 2 is 4. Plus negative 28 gives us negative 24. Times negative 2 is going to be 48, and then plus negative 48 gives us 0. So we have x minus negative 2 as one of our factors, and then the other factor is the quotient represented by these numbers here. So this is 1x to the second power, because we started with third power. This is minus 2x, and then minus 24. This looks very factorable. I at least have to try. So things that multiply to negative 24 and add up to negative 2. We got 1 and 24 doesn't work, 2 and 12 doesn't work, neither does 3 and 8. How about 4 and 6? Well, positive 4 and negative 6 adds up to negative 2, so let's use that. So we have x plus 2, x plus 4, and x minus 6. Zeroing each of these out gives us negative 2, negative 4, and positive 6. This problem, which is on the honors problem set for this homework, is a bit of a doozy. We noticed this is fourth power, so we're going to have to do a little extra on this one, but we're not afraid. So first off, are there any common factors that we can take out of this whole thing if we're trying to see where this equals 0? It looks like there are not. We can't take a 2 out of everything, and there's nothing else that's really going to work. So rational roots theorem it is. I'm going to need factors of negative or positive 12 plus or minus factors of 12 divided by factors of my lead coefficient 10. That's going to generate my PRR list. So factors of 12. We have 1, 2, 3, and then 3 times 4, 2 times 6, and 1 times 12. So no huge surprises there. But now I have to divide all of these by all the factors of 10. Well, 1 is one of the factors of 10, and that just gives us all the originals here. 2 is also a factor of 10. So we've got 1 over 2. 2 over 2 is just 1. Don't need to rewrite that. We have 3 over 2. 4 over 2 is 2. Already got it. 6 over 2 is 3. Already got it. 12 over 2 is 6. Already got that. So we move on to the next factor of 10, which is 5. So we've got 1 over 5, 2 over 5, 3 fifths, 4 fifths, 6 fifths, 12 fifths. So all of those are unique. And then finally, the last factor of 10 is 10. So we have 1 over 10. 2 over 10 is just 1 over 5, which we've already got. 3 over 10 is new. 4 over 5 is really 2 fifths. 6 over 5 is 3 fifths. And 12 over 5 is 6 fifths. So that's all our unique factors. All right. So let's go ahead now and start plugging these in until we get a 0 out of this. And I'm going to use Desmos for this, definitely. So here I am on Desmos. I'm going to write my f of x function out so I can plug things in. So we got 10x to the fourth minus 11x cubed minus 42x squared plus 7x. And we have a plus 12 as well. Let me go down now and start plugging stuff in. I'm just going to start on the left side of my list, and I'll just keep going. So we've got F of 1 doesn't work. That's negative 24. F of negative 1 is negative 16. F of 2 doesn't work. Negative 2 doesn't give me a 0. 3 doesn't work. Negative 3 doesn't work. How about 4? That doesn't work. Negative 4 definitely doesn't work. 2,576. No, thank you. Let's try 6. Nope. And negative 6, even bigger nope. So we're getting further and further away from 0. But let's just keep going. 12. Nope. And negative 12. Like, this is just way out in left field. So I tried to avoid it, but we have no choice. We're going to have to start using these fractions here. So let's start with 1/2. 1/2 gives us 4.25, which seems more reasonable, but still is not what we need. How about negative 1/2? Ah, there we go. That gives us 0. So negative 1/2 is one of our roots. F of negative 1/2 is 0. Good times. So we're going to use negative 1/2 with synthetic division on this monster here. So let me write out my coefficients. We've got 10, negative 11, negative 42, 7, and 12. And we're plugging in negative 1/2 here. Here's my division line. Bring down that 10. Negative 1/2 times 10 is going to be negative 5. You're basically dividing things by negative 2 here. And plus negative 11 is negative 16. Negative 16 times negative 1/2, that's going to be 8. Plus negative 42 is negative 34. Times negative 1/2 is going to be 17. Plus 7 is 24. Times negative 1/2 is negative 12. Plus 12 is 0. And the reassuring thing is, if you're worried about messing this up, I mean, this 0 is how you know you did it correctly, because you already know it's supposed to come out to 0. So we've got our original factor of x minus 1/2, or negative 1/2 rather, so x plus 1/2. And then we have this 10 is really 10x to the third power, because we started with fourth power. This is negative 16x squared, negative 34x, and plus 24. All of that equals 0. So I'm going to have to go probably another round here, but let me check real quick. Since there's 4 terms, is it possible I might be able to do this one with grouping? Well, a 10 to 16 ratio, that's like 5 over 8. 34 to 24 is not a 5 over 8 ratio. It's a 17 to 12 or whatever. So grouping, it turns out, is not going to work out so well here. So we really do need to keep going with rational roots. So I'm going to create a new function for this. I'm going to call this the g function. That's just going to be this quotient piece of this factorization. And I'll start plugging things into the g function. Now there is a little bit of good news. I don't have to plug in any of the stuff that didn't work. So 1 through 12 and positive 1/2, I don't need any of that, because if it didn't work for the original, it's not going to work for a smaller version of the original. So we'll start with negative 1/2, and we'll just keep going along our list here. So I'm back on Desmos now, and I'm just going to completely clear all of this out. And I'm going to write the g function now. G of x equals 10x cubed minus 16x squared minus 34x plus 24. And let me go ahead and plug some things in there. So we've got g of, we have to try negative 1/2 because that worked once. It might work again. It looks like it's not going to work again though. 35.74. No thanks. So let's do 3/2 next. Positive 3/2. That doesn't work. How about negative 3/2? That doesn't work. 5.25. What's next on the list? 1/5. So positive 1/5. Nope. Negative 1/5. Nope. How about 2/5? That doesn't work. Negative 2/5. Nope. All right, let's try 3/5. Ah, jackpot. That one worked. So g of 3/5 is 0. So we are now going to break down the g function here with synthetic division on 3/5. So my new coefficients, we've got a 10, negative 16, negative 34, and 24. And again, we're plugging 3/5 into this synthetic division. So let's bring that 10 down initially. And then when I multiply by 3/5, I'm really dividing by 5 and multiplying by 3. So 10 divided by 5 is 3, or is 2 rather. 3 times 2 is 6, so that's 6 up there. plus negative 16 is negative 10. Negative 10 divided by 5 is negative 2, times 3 is negative 6, plus negative 34 is giving me negative 40. Negative 40 divided by 5 is negative 8, times 3 is negative 24, which added to the 24 gives us 0. So we have the x plus 1/2 that we still need to include as a factor. We now can add to that the x minus 3/5, that's another factor. And this 10 here represents 10x to the second power, because this was really 10x cubed this was representing here. And then we have a minus 10x minus 40. So we're breaking it down a little bit more. Now before I go ahead and try to solve this quadratic in here, it looks like I could divide all of these by 10. I could factor out a 10, but since it's a constant, I'm also allowed to divide everything by that. So rewriting all of this, this is going to be just 1x squared minus 1x minus 4, all of that equaling 0. And at least I can attempt to factor this thing. So are there numbers that multiply to negative 4 and add up to negative 1? 1 and 4 doesn't work, neither does 2 and 2. So this is unfactorable, which means I'm going to have to use the quadratic formula or completing the square on it. So we'll go to the next slide for that. So we've got this original factorization from the previous slide. Let's go ahead and use quadratic formula on this now. So in case you need a little memory refresher here, that was negative b plus or minus square root of b squared minus 4ac all over 2a. So this is going to be negative 1, that's the b value here, plus or minus square root of negative 1 squared minus 4 times our a value of invisible 1 times a c value of negative 4, all over 2 times the a value 1. Simplifying this a little bit further, this is going to be positive 1 out here and positive 2 down there. And then inside we've got 1, and this is going to be a plus 16 if we multiply that out. So this is going to be 1 plus or minus the square root of 17 over 2. And that gives us our other two answers here. So just going back and writing out all the answers, we have negative 1/2 for this first parentheses, 3/5 for the next one, and then 1 plus or minus radical 17 over 2. And this one is finally done.